Listen to that sound. That's the sound of modern air defense going bankrupt. The missile that just launched? $4 million. The target it just destroyed? $20,000. Welcome to the future of warfare, where being cheap is more powerful than being fast. For the last 40 years, military aerospace engineers spent billions of dollars making cruise missiles faster, stealthier, and more sophisticated. Supersonic speeds, radar-absorbent materials, encrypted guidance systems. The goal? Undetectable, unstoppable. And then Iran built this, the Shahed-136. Speed, 185 kilometers per hour, slower than most cars on a highway. Stealth, 0. You can hear it from miles away. Technology, 1980s commercial electronics. Cost, $20,000. It is slow, it is loud, it is incredibly stupid, and it's destroying the world's most advanced air defense systems. Watch this. A $4 million Patriot missile locks on to the Shahed. The interceptor launches, Mach 4 speeds, perfect precision. The drone is obliterated. Mission accomplished, right? Wrong. $4 million to destroy a $20,000 target. 200-to-1 cost ratio. Now imagine Iran launches 100 of these drones in one night. Cost to attacker, $2 million. Cost to defender, $400 million. And they do this every single night. For a month. Your missile stockpiles run dry, your defense budget collapses, your airspace becomes defenseless. This is the Shahed-136, a piece of terrifyingly simple, low-tech engineering designed to do one thing: completely bankrupt the world's most advanced air defense grids. Let's break down what makes this drone so devastatingly effective, because it's not the technology, it's the economics. The body? Composite honeycomb. There's no radar-absorbent titanium here, no carbon fiber, no exotic materials. The Shahed-136 is built from cheap fiberglass composite and foam core honeycomb panels. The same stuff used in civilian aircraft and racing boats. It's assembled in segments like IKEA furniture, so you can pack 10 drones flat in a shipping container. The wings, pure aerodynamic efficiency. The Delta wing shape isn't just aesthetically cool, it's a lift generation hack. The entire body of the aircraft acts as a lifting surface. At slow speeds, 185 kilometers per hour, this shape generates massive lift while providing huge internal volume for fuel. And that fuel capacity is what gives it 1,000 to 2,500 kilometer range, enough to fly from Iran to Israel or from Russia deep into Ukraine. The engine? A literal lawnmower motor. This is the heart of the flying moped comparison. The Shahed-136 uses a Matto MD-550 engine, 50 horsepower, 4-cylinder piston engine, reverse engineered from a German Limbach L550E civilian aircraft engine. Runs on basic gasoline, not jet fuel. There are no complex jet turbines, no afterburners, no high-tech fuel injection. It's mechanically identical to engines you can buy online for $17,000. The propeller is a simple two-bladed pusher design, cheap, easy to manufacture, easy to replace. And this is what creates that distinctive, terrifying buzz. Ukrainians call it the flying moped. Israelis call it the lawnmower of death. The navigation, off-the-shelf technology. Forget military-grade encrypted targeting systems. The Shahed uses commercial GPS antennas, the kind used in agriculture drones. GLONS, Russian GPS, basic inertial navigation. You program GPS coordinates on a laptop. You enter the target building's location. You launch it from a truck. And it blindly flies to that point until it crashes. No pilot, no real-time adjustments, no complex AI. Inspections of downed Shaheds found 4G modems, like in cell phones, Texas Instruments processors, Chinese voltage converters, Polish fuel pumps, all bought commercially, all sanctions evaded through shell companies. Total manufacturing cost is $20,000 to $50,000. And with that $20,000 investment, you force the enemy to spend $4 million to stop you. That's not warfare, that's economic asymmetry. Okay, so the Shahed is cheap, but how does something so slow, 185 kilometers per hour, travel over 1,500 kilometers to hit its target? For context, an F-16 flies at 2,400 kilometers per hour. The Shahed flies at 7% of that speed. It's slower than most highway traffic. So how does it work? The answer is lift-to-drag ratio. The delta wing is incredibly efficient at slow speeds. The wide, triangular shape creates a massive lifting surface, and because there's no fuselage separate from wing design, the entire body is fuel storage. Think of it this way. A normal cruise missile is like a race car, fast, powerful, but burns fuel quickly. The Shahed is like a hybrid sedan, slow, but it can drive across the entire country on one tank. At 185 kilometers per hour, the little 50-horsepower engine sips fuel. It can fly for 6 to 8 hours on a single tank. And because the airframe is so efficient, it can carry a 40 to 50 kilogram warhead without sacrificing range. 40 kilograms sounds like much, but it's enough to punch through a building's roof, destroy radar installations, crater runways, ignite fuel depots. And when you send 100 of them in a single night, you don't need precision, you need volume. Here's the thing about the Shahed-136. One drone is useless. It's so slow that a guy on a rooftop with a heavy machine gun can shoot it down. Anti-aircraft cannons obliterate them. Fighter jets intercept them easily. But they're never launched alone. This is the Shahed launch system. Stacks of 5 to 10 drones mounted on disguised civilian trucks or shipping containers. Each drone is launched with a disposable rocket booster that drops away after a few seconds. And they don't launch from one location, they launch from dozens of trucks scattered across hundreds of kilometers.
So when Iran or Russia launches an attack, you don't see one drone, you see 100 drones, all flying different routes, all converging on different targets. And here's where the math gets brutal. Attackers cost: 100 drones times $20,000 equals $2 million. Defenders options. Option 1. Shoot them all down with Patriots. 100 intercepts times $4 million equals $400 million. Option 2. Scramble fighter jets. Flight hours, fuel, pilot fatigue. Cost: $50,000 to $100,000 per sortie. Problem: fighters can't stay in the air 24/7. Option 3. Use cheap AA guns. Cost: $100 per burst. Problem: only effective if the drone flies directly overhead. Now imagine this happens every single night for 30 days. Attacker spends $60 million, 3,000 drones. Defenders spend $12 billion with Patriots, or hundreds of millions with jets. And here's the nightmare: you run out of interceptors. In March 2026, the US admitted it had fired over 800 Patriot and THAAD interceptors in just 5 days of conflict with Iran. Cost: over $4 billion in interceptors alone. And you can't just make more Patriots overnight. Patriot production: around 550 missiles per year, US and allies. Shahed production: Iran can build thousands per year in converted factories. The Shaheds don't need to destroy every target. They just need to keep coming until you can't afford to stop them. It's not a weapon, it's a siege engine. The Shahed-136 has caused a global panic because every military planner realized the same thing. You cannot fight a $20,000 drone with a $4 million missile. So, militaries are doing something unprecedented, going backward in time. Meet the Gepard, a 1970s-era West German anti-aircraft cannon. 2 radar-guided 35mm cannons, firing rate 1,100 rounds per minute. Each tungsten round costs about $30. To destroy a Shahed, maybe $300 worth of ammunition. Germany sent dozens of Gepards to Ukraine specifically to hunt Shaheds, and they work. Ukrainian forces report high success rates against slow-moving drones. But here's the irony. From the 1970s to 2000s, militaries phased out traditional AA guns. Why? Because modern jets fly too fast. Missiles were better. But now, with slow drones flooding the battlefield, they're bringing them back. Option 2. Electronic warfare. GPS jamming can confuse Shahed navigation. Cost per engagement? Pennies. Just electricity. Problem? Iran is adding anti-jamming antennas and inertial guidance backups. Option 3. Directed energy weapons. Israel's Iron Beam laser system. Cost per shot? $2. Literally just the electricity to fire the laser. This is the ultimate counter to the Shahed's economic warfare. A weapon made of light that costs almost nothing to fire. But Iron Beam isn't deployed at scale yet, and until it is, the Shaheds keep coming.
The Shahed-136 isn't a technological marvel. It's an economic weapon. It proves that in the 21st century, mass production and cheap civilian parts can completely overwhelm the most sophisticated, expensive military hardware on Earth. And the scary part? Anyone can build them now. In December 2025, the US unveiled Lucas, a Shahed-136 clone built from reverse-engineered wreckage. They're using it against Iran, the same drone Iran used against Ukraine. Russia is building thousands. Iran is exporting them. Hezbollah has them. The Houthis in Yemen have them. And the blueprints are out there. Every component is commercially available. GPS antennas, Amazon, engines, European suppliers, processors, Texas Instruments, fuel pumps, automotive parts stores. Which means in 10 years, it won't just be nations with these weapons. It'll be anyone with $20,000 and a laptop. The F-35 costs $80 million. It's stealthy, it's fast, it's incredibly advanced. For the same price, you could build 4,000 Shaheds. So here's the question. In a world where a $20,000 drone can bankrupt a $4 million defense system, does the era of expensive multi-million-dollar fighter jet finally end? Or do we just accept that the future of war isn't fought by the richest military? It's fought by whoever can afford to keep launching. So here's my question for you. Does the Shahed-136 prove that the era of expensive high-tech weapons is over? Or will directed energy weapons like lasers solve this economic trap? Let me know in the comments. I'm genuinely curious what you think. And if you want to see how Israel's Iron Beam laser system is designed to counter exactly this threat, I broke down that technology, link in the description. Hit subscribe. This channel dives deep into the economics and engineering reshaping modern warfare. Thanks for watching. I'll see you in the next one.